Hi guys, how are you? I hope you are doing well. So today we're gonna start chapter 15. So in chapter 15 we're gonna study integrals, double and triple integrals. So first, before introducing double integrals, so let me just remind you, in the case of a function of single variable, so if you have, let's say, f of x, a function of single variable, just one variable x, f of x, let's say, continuous on the interval AB, okay? And let's say f of x is positive or 0, okay? Then, we have the following picture. So this is your x here. So let's say this is A here, this is B. And so let's say here is your function f from A to B. So this is, so here, this is f of x, right? So here, this is your f of x. So what would be the, so what's the interpretation of the integral of f of x from A to B? So the integral of f of x from A to B, that will be the area of the region between the x-axis and the graph of f of x. So that will be the area of this region here. So this region here. So the integral of f of x from A to B, that's the area of the region which is between the x-axis and the graph of f of x. Okay, so that's the interpretation of the integral of a function of single variable. Okay, now now let's move to the double integral. So in case of double integral, so now double integral. So now we have a function of two variables. Let's say f of xy. So we have f of xy. So that's your z. So z is equal to f of xy. Let's say this function here, f of xy, is continuous on. It's not just it's continuous on a rectangle. Say AB cross CD. Okay, and suppose that this function f here is positive or 0. Okay, so basically we have this following picture here. So this is the x-axis, it's your y-axis. Okay, this is your y-axis, and then of course, then this is your z here. Okay, and so we have a rectangle AB cross CD. So your x is between A and B. So here you have A and B. Okay, so this is for the interval for x. Now the interval for y, so y would be between C and D. So let's say y here, this is C and this is D. So when I say AB cross CD, it means the following rectangle. So here, this is ABCD. So you get this rectangle here, this region here. Okay. So you see your x is between A and B. This is your x here is between A and B, and your y, so along the y-axis, the y variable is actually between C and D. Okay, so when you say AB cross AD, it means this interval here cross this one here, so you get the whole integral, the rectangle here, this one here. Okay, now you have the function f of xy. So now you're gonna graph the image of the rectangle, of this rectangle by the function f. So if you let's say the graph of f of x, y, the graph of f of x, y would be something, let's say, which looks like this here. Okay, so this is the image of the rectangle by the function f. So this is f of x, y. Okay, so for example, so let's say this point here, this one here, it goes here. Okay, this one here, it goes to this one here. Okay, this point here, it goes to the one here, this one here. That would be the image of this point here. And finally, this one here, its image would be this one here. Okay, so now you don't get an area, but you get a solid, right? So the solid here, which lies between the rectangle and the function f of x, y. So you get this solid here, this one here. Okay, so actually the volume of the solid, the green, the green solid, which lies, between the rectangle, the red rectangle, and the graph of f of x, y, the blue surface. So the volume of the solid which lies between the rectangle and the graph of f of x, y, that will be the double integral of f of x, y. Okay, so what I'm saying is the volume of the solid that lies between the rectangle so this rectangle here, the red rectangle, okay, and the graph and the surface f of xy. So when I say the surface f of xy, that will be this blue surface here, the blue surface. That's the graph of f of xy. Okay. So what I'm saying is that the volume is actually given, the volume of the solid is actually given by the double integral of f of xy. So dx dy. Okay, so now we have two variables, so there'll be f of xy dx dy. Okay, so that's the interpretation of this double integral. What we are saying, it gives you basically the volume of the solid which lies between the rectangle, your rectangle, and your surface f of xy. Okay, now how do we evaluate a double integral? Okay, so let's say you have a double integral, so f of xy dx dy. So first, we need to understand here, so when you write dx dy, it means that the order of integration is x first and then y. So here, this notation here, it means, so dx dy means we integrate first with respect to x, and then we integrate with respect to y. Respect to y, okay? So dx dy means first you integrate with respect to x, and then you integrate with respect to y, okay? So what we do is the following. So let's say you have, so here we have f of x, y, and dx, and then dy, right? And let's say here we have ab, and then you have here cd, okay, your x. So this notation here means first we integrate with respect to x. So here, so first we integrate with respect to x. So your x is actually between a and b. So here x is between a and b. Okay. And what we do is we integrate with respect to x, assuming y is a constant. So we integrate with respect to x, assuming y as a constant. Okay, so you suppose that y is a constant and you integrate with respect to x. And again, here the order is really important. So here when you write dx dy, it means first you start with the integration with respect to x, and your x is actually between a and b. Okay, so x between a and b, and then once you are done with x, then you integrate with respect to y, and so your y here is between c and d. Okay. Okay. So first you integrate with respect to x, assuming y is a constant, and then we integrate. With respect to y. Okay. So let me do an example so you can see how it works. Example. Okay, let's say double integral x y squared, here 1 2 and here 1 4. Okay, dx dy. Okay, this is for my first example. So as I said, here the order of integration. So you integrate first with respect to x. Okay, so we start with respect to x, and when you integrate with respect to x, you consider y as a constant. So when you say x times y squared, it means x times a constant. It's like saying, I don't know, for example, 3x. What's the integral of 3x? Okay, you just ignore the constant, right? And you integrate x, and the integral of x would be x squared over 2, right? So the integral here. So first you keep this here. You keep 4 1 here. So this is 4 1. You keep dy, because, as I said, the order of integration here is that we integrate first with respect to x. Okay, so we keep dy, we keep the 1 4 here, and then what we do, we integrate this here. Okay, so as I said, integral of x y squared, we integrate with respect to x. It means that y is a constant, right? So what would be the integral of a constant times x? For example, what would be the integral of 3x? Well, it would be 3x squared over 2. Okay, so same thing here. So that would be integral of x here. So that's x squared over 2 times y squared. Y squared, I mean, again, y squared is just a constant. So it's just times y squared. And then here, your x is between 1 and 2, right? So here we need 1 and 2. So we need to evaluate the integral between 1 and 2, and we have to plug 1 and 2 into in x. You replace x here because that's the order of integration, right? We said we integrate first with respect to x. So we replace x here by 2 and then 1, right? So that will be equal. So we have again this 1, 4 here. And then you replace x by 2. So that will be 2 squared over 2 times y squared minus, and then you replace x by 1, so that's minus 1 squared over 2 times y squared. Okay, and then we have the dy, and then there's this dy here. All right, so I just integrated with respect to x, assuming y is a constant, and then I plug 1 and 2 in x, okay, and then take the difference, of course. So what will be the difference? So here's 1, 4. So it's 2 squared over 2. That will be 2y squared. So 2y squared minus half y squared dy. So 2 minus half, that will be 3 halves. So 1, 4 here, 3 halves y squared dy. Right? And then we can just now integrate with respect to y. Okay, so you see here there's no x, there's just y. So now I can just integrate with respect to y. So what will be the integral here? It's 3 halves, which is constant, times integral of y squared. Integral of y squared is y cubed over 3, of course. Right? And we evaluate, so the integral between 1 and 4. So first replace y by 4. So that's 3 halves, 4 cubed over 3 minus 3 halves, 1 cube over 3. So that will be equal to, so here 3 cancel out. So this is 4 cubed, 16 times 4, 64, 64 over 2. That's 32. So this is 32 minus a half, right? So that will be 63 over 2. So that will be the answer. And that will be actually the volume of the solid. So this is actually the volume of the solid between our rectangle and the surface given by the function f of xy. So that will be the volume of this solid here. Okay. Let's do another example. So let me just mention here the importance of the order of integration. So we can have, for example, let's say here 1, 2, and here 0, 1. Okay, and then let's say here we have just x plus xy. Okay, and then we have dy dx. So here in this example, so we need to be careful. So first, because we have dy first, so then we integrate with respect to y first. Okay, so we start with y. So you see here, so we start with y, and y is between 0 and 1. Okay, y is between 0 and 1. And when you integrate, so we integrate with respect to y, assuming x as a constant. So integrate with respect to y, assuming x constant. Okay, so that will be equal. So we keep, you keep this 1, 2 here, and this dx. So we have this integral here, 1, 2. We have this dx here, right? Now we're going to integrate. So what's the integral of x? We integrate with respect to y, right? Because that's the order of integration. We have dy first and then dx. So we integrate first with respect to y. So what's the derivative of, integral of x? Well, again, x is a constant. So what's the integral of a constant with respect to y? For example, if you have 3, what will be the integral of 3 with respect to y? Well, the integral of 3, a constant, that will be 3y, right? If you have 3, the integral of 3, that will be with respect to x, let's say, that will be 3x. So now we have variable y. So the integral of phi, that will be phi y. So if you have x, which is constant, then the integral of x will be xy. So here is going to be xy plus, this x is a constant, times y. So when you integrate a constant times y, you just keep the constant and you integrate y, right? So you keep the constant x and you integrate y. So the integral of y would be y squared over 2, right? Y between 1 and 0, right? So now I'm gonna replace y by 1 and then 0. So here, replace y by 1 and 0. So let's just keep the 1, 2. So this is 1, 2 here. This is your dx. And now I'm going to replace here y by 1. So that's x times 1 plus x times 1 squared over 2 minus, and then we're going to subtract. So now we're going to replace y by 0. So that's x times 0 minus x times 0 plus x times 0 squared over 2. Okay, so that'll be equal. So we have 1, 2. This is x plus x times 1/2. So this is x plus x over 2 minus, this is just 0, 0, so it's just 0. So there'll be x plus x over 2 dx. Now that will be x plus x over 2. That's the 3/2 of x dx. So we're gonna just integrate now with respect to x. So we have a constant 3/2. Integral of x, that will be x squared over 2. And we evaluate between 1 and 2. Okay, so you replace x by 2 as usual. So 3/2 times 2 squared over 2 minus 3/2 times 1 squared over 2. So that will be, of course, here this is 4 over 4 cancel out, so this is just 3. And so that will be 3 minus, and here that will be 3 over 4. Right? So that will be 12 over 4 minus 3 over 4. So that's 9 over 4. Okay. Anyway, my point, guys, is that you have to respect the order of integration here. So again, if you have dx, dy, so you integrate first with respect to x, assuming y as a constant, and then you integrate with respect to y. Or you can, if you have dy, dx, then you integrate with respect to y, assuming x is a constant, and then you integrate with respect to x. Okay. Now, you may ask, so here's an interesting question. What's the difference between if, let's say you have, so the difference, is there any difference between, so let's say you integrate first with respect to x, so this is f of x, y, here, dx, dy. So let's say dx here is between a and b, so x here is between a and b, and y is between c and d. So if you were to change the order of integration, okay, so the question is there a difference between this integral and if you were to change the order of integration? So if you integrate with respect to y first and then x, of course you need to keep here the corresponding intervals. So your y is between c and d, and your x is between a and b. Okay. Well, the answer is if f is continuous on the rectangle AB cross AD, then actually both integrals are equal. So you can interchange the order of integration. So that's actually called the Fubini theorem. So you have f of xy. Of course, you need f of xy to be continuous on, let's say, AB cross CD. Okay, then the integral, double integral. So dx dy, x between a and b, y between c and d is the same, is equal to the double integral of f of xy, dy dx, y between c and d, and x between a and b. Okay, so if you were to change the order of integration, okay, then you get the same integral. Both integrals are equal. Okay, so here be careful again. So you have the region is a rectangle. Your x is between a and b. Your y is between c and d. Here your y is between c and d. Your x is between a and b. So it's the same region. Okay, that's really important, of course. So so let's do an example. Okay, so let's say you have xy squared dx dy. Let's say your x is between 0 and 1. Okay, and y is between 0 and 2. Okay, and I'm going to compare this to same integral, but I'm gonna change. I'm gonna interchange I'm gonna change the order of integration. So I'm gonna start with the integration with respect to y first. So y would be between 0 and 2, and x between 0 and 1. Okay, so let's compute both integrals. So first we have xy squared dx dy. X is between 0 and 1, y is between 0 and 2. So again, guys, here you start first with x, right? So here we integrate first with respect to x. So you assume of course y constant. Okay, so that will be equal to, so we integrate with respect to x, of course, first. So if you integrate with respect to x, y is a constant, y squared will be also a constant, and so what will be the integral of x times a constant? So that will be the constant times x squared over 2. So that's x squared over 2 times the y squared. Okay, so that's the integral, and it's between 0 and 1. So here the interval evaluated between 0 and 1. Okay, and of course we keep the interval of integration of the y. So that's here, it's 0, 2 again, and here is the dy. Okay, so let's compute this. So now we replace x, right? We integrate with respect to x. So we need to replace x by 1 first. So we have this 0, 2. So that'll be 1 squared over 2 y squared minus 0 squared over 2 y squared dy. So that will be equal to the integral from 0 to 2. So this is just 0. This is y squared over 2 dy. So now we are done with x. Now we can integrate with respect to y. So what will be the integral with respect to y of y squared? That will be y cubed over 3, right? And times the constant, which is half, so times 2 here, and evaluated between 0 and 2. So now replace y by 2. That's 2 cubed over 3 times 2 minus, and then you replace y by 0, so that's 0 cubed over 3 times 2. So this is of course 0. Now 2 cubed, that's 8. 8 over, here it's 2. That's 4. 4 over 3. So this is equal to 4 over 3. Now let's change the order of integration. So now I'm going to compute this right side here. So I'm going to integrate first with respect to y. So we have, again, xy squared, but now dy dx. So first with respect to y, your y is between, keep in mind, your y is between 0 and 2. So y is between 0 and 2, x is between 0 and 1. Okay. So first, we integrate with respect to y here. So you assume, so integrate with respect to y, assuming x constant. So what's the integral of x y squared with respect to y, assuming x is a constant? So that will be just the constant times the integral of y squared, which is y cubed over 3. So that will be equal to, of course, we keep this dx here, this 0, 1 here. So this is 0, 1 here, this is dx here. And then we integrate with respect to y. We said it's constant times y squared, so it's constant times y cubed over 3 from over 3 here. So y cubed over 3 evaluated between 0 and 2. Okay, so that will be, again, here is 0, 1. Now you replace y by 2 and 0. So let's replace y by 2. So that would be x 2 cubed over 3 minus x times 0 cubed over 3 dx. So this is just 0 here. This is 2 cubed over 3. That's 8 over 3x. Integral from 0 to 1 dx. So now we are done with y. You can just integrate with respect to x. The integral of 8 over 3x, that's 8 over 3 x squared over 2 from 0 to 1. So now we just replace x by 1. So that's 8 over 3, 1 squared over 2 minus 8 over 3 times 0 squared over 2. So this is, of course, this is 0. So it's 8 over 3 times half. So it's 8 over 3 times half, which is, of course, 4 over 3. So you see, we get the same answer. Okay, so so we verified the Fibonacci theorem. All right, so we can, if you have a double integral, you can just you can always interchange the order of integration. Okay, and that will be it gives you the same integral. Okay. So now let me just say a couple of words about triple integrals, so we can extend the same the double integrals to triple integrals. Okay, so we can extend to triple integral. Actually, you can extend it to any dimension, so triple integral. So now if you have a triple integral, it means you have, a function of three variables, f of x, y, z, and then you're gonna have dx, dy, dz. Okay, and x is between a and b, y is between c and d, and z is between e and f. Okay. So let me just say one word here, guys. It's an important remark. So if you integrate, actually, if f of x, y, z is equal to 1, then this triple integral, so we're going to have triple integral here, 1, right, dx, dy, dz, so x between a and b, y between c and d, z between e and f. This is actually equal to the volume. So this is the kind of, this is like the, so this is the interpretation of a triple integral. So if this function f of x, y, z is just equal to 1, then actually this will be the volume of the parallelepiped, right? So parallelepiped with so AB cross CD cross EF. Okay, so it would be this this thing here. So let's say this is your X, so this is your Y, this is Z. So your X here is between A and B, y between C and D, and Z, the height Z is between E and F, okay? So you're gonna get something which looks like, okay, so the parallelepiped would be something which looks like the following. I'm gonna try to do my best here. Here. Okay, so this is here. Okay, so this whole thing here, okay, so this is your parallelepiped. So parallelepiped. Okay. So the volume of the parallelepiped would be equal to the triple integral of 1 dx dy dz. Okay. So so for example, let's do an example here. Example. So let's say you have triple integral. Let's say here's 1 dx dy dz. Let's say x between 0 and 1, y is between 0 and 2, and z between 0 and 3. Okay. So first, of course, this is the order of integration. Same story. First, we integrate with respect to x, then with respect to y, then with respect to z. So that will be equal to, so we're gonna integrate with respect to x first, right? So here, first with respect to x. So you're supposed to consider y and z as a constant. Okay, so you're supposed to consider here. So integrate with respect to x, y, and z are constant. But anyway, here there's no y and z, it's just 1, so integral of 1 with respect to x is just x. So that will be equal to, so we have this 0, 3, then you have this 0, 2, and then we said integral of 1, that will be just x. So it's x between 0 and 1, right? dy dz. So that will be equal to, again, 0, 3, then integral from 0 to 2. You replace x by 1 and then by 0, so it's 1 minus 0. And then you have dy dz. Okay. Next, we integrate with respect to y. And we consider z as a constant, but there's no z anyway. So it's just the integral of 1 with respect to y, which is equal to y. So this is, again, 0, 3 here, dz, integral of 1, which is just y. Between 0 and 2, so you replace y. So again, have the integral from 0 to 3, you replace y by 2 and then by 0, so that's 2 minus 0 dz. So it's just the integral from 0 to 3, 2 dz. Now, what's the integral of 2 with respect to z? Well, that's 2z from 0 to 3. So that will be equal to, you replace z by 3. So 2 times 3 minus 2 times 0, so that will be equal to 6. Okay. Anyway, so here, again, this is, the 6 here represents the volume of the parallelepiped. Uh, 0, 1 cross 0, 2 cross 0, 3. Okay. Of course, now another example. Let's do a last example. So let's say now we have a function here, not just one, but let's say you have x z plus y z. So dx, dy, dz, and again x between 0 and 1, y between 0 and 2, and z between 0 and 3. Okay. So again, you first in order of integration, so we start with the integral with respect to x. So you consider, so here you consider y and z as a constant. So of course, guys, you may ask about if we can also apply Fibini theorem to the triple integrals, right? If this function is continuous, can we just, if you interchange the order of integration, do we get the same integral? The answer is yes. Okay, so you can extend actually the Fibini theorem to triple integrals. But anyway, so let's do this here. You consider y and z as a constant. So here you have x times z, right? So you integrate with respect to x. Z is a constant, so you can just ignore this z. It's just a constant. You integrate x, right? So it's x squared times 2 over 2, sorry, times z plus. This is what. So first, of course, you have this 0 3 here. This is 0 2. Here's my dy and here's my dz. Okay. Now next, y times z. Both y and z are constant, so y times z would be also a constant. And what's the integral of a constant with respect to x? That will be the constant times x. So that will be my constant, which is yz times x. Okay, and then you evaluate between 1 and 0. So you replace now x by 1 and then x by 0. So that will be, again, integrals from 0 to 3 to 0 to 2, x by 1, so 1 squared over 2, z plus y, z times 1, minus, and now replace x by 0, so that'll be 0 squared over 2, 0, z plus y, z times 0, right, dy, dz. Okay, so this is of course just 0 here, because everything is 0. And then here that will be half of z plus yz. So we're gonna have 0 3, 0 2, here's dy, here's dz, but here we have half of z times plus yz. So half of z plus yz. So now next we're gonna integrate with respect to y, right? So here you integrate with respect to y, so you consider z as a constant, so integrate with respect to y. Of course, x, we are done with x, so there is no more x, okay? Now it's just y and z. So we will integrate with respect to y, assuming z as a constant. Okay, so that will be equal to, so we have this 0 3, so half of z. Z is a constant, half is a constant, so half of z is just constant, and integral of constant with respect to y, that will be the constant, which is half of z times y, plus here y times z. Z is a constant, so you can just ignore the constant, and integral of y will be y squared over 2 times the constant. And you evaluate y between 0 and 2, so you have to replace y by 2 and then by 0. Okay, so we have this dz, of course. So let me just write down here. So this is for dz. Now you replace y by 2. So that's half z times 2. Half of z times 2. And then plus y squared over 2z. So that's plus 2 squared over 2 times z. Right? You replace y by 2. And then you replace y by 0. So that's minus. And then you replace y by 0. So that's half of z times 0 plus 0 squared over 2 times z. So of course this thing here is just 0. So it's just integral from 0 to 3, half of z times 2. So 2 cancel out here. And so that will be z plus 2 squared, which is 4 over 2, so that's plus 2z dz. So this is actually integral from 0 to 3, so z plus 2z, that's 3z dz. Now, what's the integral of 3z with respect to z? So that's 3z squared over 2 from 0 to 3. So now I can just replace z by 3, so that's 3 squared over 2 minus 0 squared over 2. So that will be equal to 27. So over 2. So this is 0, of course, and that will be 27 over 2. So that will be the answer. Anyway, guys, I guess I'm gonna stop here. You can find more examples in the lecture notes, and I will see you next time for more about the double and triple integrals. See you next time. Thank you.